So last time we introduced a new method to find probability density function, and we proved the formula given by the theorem. So today we're going to look at some examples on how to apply the theorem. So here we're going to use the formula just introduced in the previous theorem. So first, we are going to solve for y. So we're going to express the given variable in terms of the new variable. So I can subtract 3 on both sides and then divide by -4 on both. And that means the inverse function this is H inverse of u. Because the given function is -4y plus 3, so the inverse is -1/4 u plus 3/4. And from the given PDF, we know small f of y is not 0 when y is between 0 and 1. So if y has to be between 0 and 1, that means -1/4 u plus 3/4 has to be between 0 and 1. Because that's our H inverse of u, so that's our y value. And then solve this inequality. We get u has to be between -1 and 3. So now applying the formula given by the theorem, small f of y is twice of the input and so this part is small fy, and then differentiate H inverse of u. So I'm going to do it here. Is -1/4. So it's absolute value of -1/4. And this is true if u is between -1 and +3. And then simplify. So this is how to find density function using a 6.4 method of transformation. Now let's look at some bivariate stuff. Given F, the joint density of y1 and y2, find the PDF of the sum. So for bivariate distribution, we're going to solve it in 2 steps. First step, we're going to find the joint probability density function of y1 and u. And we're going to denote it by g of y1, comma u. And second step, we're going to find the PDF of u as a marginal density of g, of the density function we found from step 1. So for this problem, what we're going to do is we're going to fix random variable y1 to be a particular value. So then u is the sum, which means this is our h of y2. And then, just like what we did before, once we have the function, we're going to find the inverse function by solving for y. So in this case, we're going to have to solve for y2. So y2 is and this is what we call h inverse of u. And because h inverse of u is y2, so we needed y2 to be greater than or equal to 0, so our u minus y1 has to be greater than or equal to 0. So now we're going to apply the theorem. Because we fix y1 as a constant, so we can think of this as just finding, just like the one we did before. So applying the formula, derivative of h inverse with respect to u is 1, and then use the specific form of the joint density and we know u has to be greater than or equal to y1 because of here, and we know y1 has to be greater than or equal to 0. So this first step, we found g, the joint density of y1 with y1 fixed and u. And the second step, we're going to find the marginal density of u. And we know marginal density is we integrate the joint density with respect to the other variable. And g is non-zero if y1 is bigger than 0. and smaller than u. So we can plug in the limits. And that gives us u times e to the negative u, which means the density function of u is and 0 elsewhere. So that's it for section 6.4.